Hi friends, welcome back to the channel. Today we are going to look at this vector triple product. So the first question to you is, how many of you remember the exact answer for these two expressions? All of us may have learned this equation, these two set of equations at some point of time in your life, but most probably we would have forgot the exact answer for these two expressions. In this video, what I'm trying to do is give you a very intuitive explanation for both of these expressions so that next time when you come across these two expressions, you will know what to do or what is there on the right hand side without simply memorizing the expression. So, without much ado, let's get started. The first question is, what you can tell me about this expression, or at least what you can tell me about the resultant or the quantity that will come on the right hand side. I will let you think for a couple of seconds. So, one thing that you can definitely tell about the output or the quantity that is sitting on the right hand side of this expression is that it is a vector. Because we are taking the cross product of these two vectors, which is a vector again. Then let's call this some vector m. Then we are taking this cross product m cross c, which will be again another vector. So on the right hand side we will have a vector. Then there is this very interesting property for the vector cross product. When you take the vector cross product of two vectors, the resulting vector will be orthogonal or will be perpendicular to the plane spanned by these two vectors. So for example, if we take, let's say m vector is equal to a cross b, then this vector little m will be orthogonal to the plane spanned by vector A and vector B. To make it more clear, let's look at an example. In this example, we have two vectors. Vector A along the x-axis denoted as 2i cap. Then along the y-axis, we have 3j cap. This is the second vector, B. Now, when I take the cross product of these two vectors, which is fairly easy. So once you do that operation, you get a vector 6k cap. So our resulting vector, I will use a different color for that one. So our 6 cap vector will look like something like this because it is pointing along the k direction or along the z axis, and it is having a magnitude of 6. So as you can see from this illustration that the resulting vector is perpendicular to the plane xy plane. What is so special about the xy plane? Xy plane is spanned by these two vectors. By when I use the word spanned, what I mean is every vector in this plane or can be written as a linear combination of these two vectors. Or to be far more specific, you can say can be written as the linear combination of the unit vectors that point along these two directions. I can take a vector divided by magnitude of a vector will give me the unit vector along that direction. Then b vector divided by magnitude of b vector will give me the unit directional vector or the unit vector along the direction of vector b. In a nutshell, this is very easy. When you take the cross product of two vectors, the resulting vector is perpendicular to the plane spanned by other two vectors. By spanned, I told you what I mean by the word spanned. It is very simple. Two vectors will always give you a plane, doesn't matter, and this illustration clearly gives you a feel about the result. So I think all of you will agree with me if I say that little m vector is perpendicular to both a and b. Now what you can tell about the right hand side vector. Let's call the right hand side vector r vector. Now I can tell about r vector that r vector is perpendicular to little m vector, because that's what we just saw. Little r vector is perpendicular to our little m vector, which in turn means that r vector lies in the plane spanned by a vector and b vector. Make sense? So this is the key concept that you need to understand when you come across vector triple product. Since the vector lies in the plane spanned by these two vectors, a vector and b vector, we can write the resultant answer like this, because it is some constant times a vector time plus some other constant times the b vector. Now everything boils down to evaluating these two constants. I'm not going into those things like how you will evaluate these two constants and all. Now I will right away, I'm going for the kill. I'm giving you the expressions and then telling you a few tricks to remember that. So these are the final expressions. So the rules goes like this. There are two terms. Rule number 1. Rule number 2. There will be always a negative sign for the second term. Rule number 3. The term 1 will always have the vector which is in the middle of this expression. Just to explain rule number 3. Here the middle vector is b. So the first term has vector b in it. Here again the middle term is b and the first term has vector b in it. So rule number 1 was there are two terms. Rule number 2, there is always a negative sign with the second term. Rule number 3, middle vector will be always there in the first term. It is not there as a dot product, it is there as it is. Make sense? Then things are fairly easy, because once you know that the middle vector is there in the first term, you know this resultant vector is in the plane spanned by a vector and b vector. So once you have b vector here, then in the second term you should have your a vector. But when you come to this expression, you know that the resulting vector as per this expression lies in a plane spanned by these two vectors, vector b and vector c. Because if vector b cross c is some vector, let's call it, I'm running out of alphabets here, let's say n cap. So the resulting vector should be perpendicular to n cap. Makes sense? Which in turn means that the resulting vector should lie in the plane spanned by vector b and vector c. So let me summarize all the things what we have discussed. I have written here one after the other. The resulting vector should be in a plane spanned by those two vectors which are in the bracket. Then middle vector will be there in the first term. The middle vector, the b vector in the two above examples. There is a minus sign on the second term. Then coefficients are the dot product of other two vectors. So with this intuitive understanding, I think you will never have to memorize the formula for vector triple product. Thanks for watching.